Questions asked in JEE Main of 2025 shift in April shift. So first question is, a solution is made by mixing 1 mole of volatile liquid A with 3 moles of volatile liquid B. The vapor pressure of P or A is 200 mm Hg and that of the solution is 500 mm Hg. The vapor pressure of P or B and the least volatile component of the solution respectively are. So let's see what are given here. So we have two components A and B. A is 1 mole, B is 3 mole. Vapor pressure of P or A is 200 millimeter Hg. Then we have been given the vapor pressure of solution. Solution is PA and PB. So we are being given here is PA plus PB is equal to 500 millimeter of Hg. We have to find vapor pressure of P or B and the least volatile component. So vapor pressure of P or B will be PB naught. So we have to calculate PB naught. Now if total pressure is given, PT is given. You know that PT is the sum of PA plus PB. That is, there is a solution in which there are two components A and B. So the total pressure will be equal to the vapor pressure of A and B. According to Raoult's law, PA is PA naught XA, PB is PB naught XB from Raoult law. So PA naught is given 200 millimeter Hg. XA will be, now let's given number of moles is given here. Number of moles is Na 1 mole, Nb 3 mole. So what will be XA? XA is number of moles of A, number of moles of Na plus Nb. So that comes as 1 by 4. So XA is 1 by 4 and PB naught is to be find out. XB will be 3 by 4. Why 3 by 4? Because there are 3 moles of B and total mole will be 4. And total of PT is also given. PT is 500. So let's see, 500, 200 of 1/4 of 200, that is 50. PB naught 3 by 4, 450 equal to PB naught 3 by 4. So 450 into 4 by 3, that comes out to be 150 into 4, that is 600 millimeter Hg. This is PB naught. Now PB naught is 600, PA naught was 200. What is PA naught? PA naught is the vapor pressure when only A is present of P or A, and PB is when only B is present. So let's see which option comes out to be 600. There are two options of 600. Second part was least volatile component. Which is the least volatile? So we have two components, one having 200, one having 600. Greater the vapor pressure, greater will be the, it will be greater volatile. That is, it has greater tendency to go in the gaseous phase. So least volatile component is A. So the correct answer is 4. That is, if there are two gases A and B, suppose there are two gases A and B, A has vapor pressure of 600 and pure B has vapor pressure of 600. A has pure vapor pressure of 200, B has pure vapor pressure of 600. That is, vapor pressure of B is more, which means B is greater in the vapor phase gaseous state, which means it has greater tendency to go in the gaseous state. That is, it is more volatile. In the question it was asked which is least volatile. Least volatile will be A. Now next go to the next question. Calcium carbonate plus 2HCl gives CaCl2 plus CO2 plus water. Consider the above reaction. What mass of CaCl2 will be formed if 250 ml of 0.76 mHCl react with 1000 gram of calcium carbonate? It's very easy question. We have to compare. I'm writing it here itself. We are given here 1000 gram. HCl is in molarity. We have to calculate the weight of CaCl2 formed. Now let's compare calcium carbonate and HCl. HCl mass is not given, molarity is given. So molarity is 0.76 m. Molarity is number of moles of solute by volume. Number of moles is given mass by molecular mass by volume. Molarity was given 0.76. Given mass we have to find out. Molecular mass of HCl is 36.5. Volume was 250 ml. That is why we multiply by 1000. Molecular mass of HCl comes out to be chlorine plus hydrogen, that is 36.5. Molarity is given. So weight comes out to be 0.76, 36.5 divided by 4, that is 0.19 into 36.5. So let's assume it to be 0.2, 36.5, which comes out to be 73, 0.73, 7.3. So weight of HCl comes out to be 7.3. Now calcium carbonate reacts with HCl. .3 is given here, and here it is given 1000 gram. So let's see. Given mass of calcium carbonate is, calcium is 40, carbon is 12, oxygen is 16, that is 48, 100 gram. So 100 gram calcium carbonate reacts with 2HCl. According to question it was 2HCl. So calcium carbonate reacts with 36.5 into 2, that is 73 gram HCl. So 100 gram calcium carbonate requires HCl 73 gram. So 1 gram requires 73 by 100 into 1000, that is 730 gram it is required. How much is present? Only 7.3 gram HCl is present, which means HCl is the limiting reagent. Now when two reactants are given, what happens is we have to find the limiting reagent which is present in less amount. If it is present in less amount, it will decide the quantity of CaCl2. For example, there are two reactant A and B. A is present in 5 gram, Suppose 1 mole A requires 1 mole B. Now suppose it is 3 mole and B is in 2 mole, so B is less. So the amount of B will depend upon the quantity of C produced, because B replenishes fast. So here HCl is limiting reagent and its weight comes out to be 7.3 gram. So how much CaCl2 will be produced? So 2 HCl gives calcium chloride. 73 gram HCl gives calcium chloride is 30.35.5 into 2, 71 plus 40, 111 gram. So 111 gram by 73 into 7.3. So it comes out to be 11.1 gram. So 11.1 gram calcium carbonate is produced. We have one answer which is closest. It comes out to be 10.545. So it is the correct answer. The approximate might have come from here, where we have taken it to be 0.19 instead of 0.2. So there isn't any problem if the options are varying very much. So this was the question from limiting reagent. Quantity of both were given. We have to first find out the limiting reagent and then find out the amount of product. Next question is, if equal volume of AB2 and XY are mixed, which of the following combinations will give a precipitate of AY2? AB2 and XY are mixed, precipitate given of AY2. So AY2, A has +2 oxidation state, Y will be +1, Y +2, because the stoichiometry gets inversed. Therefore if it is +1, it will also be +1. It gives +2 oxidation state, it have +1. So we have combination of B and X. Bx will be, because it is +1, and it will be -1. Suppose it is -1. Now if we balance it out, Y is 2, therefore X will be 2, B is also 2. Now the question is, which of the following will give a precipitate of AY2? We have masses of all the given answers. So suppose it have value C, it will have value 2C. Now when will the reactant give product? KSP value is also given. KSP at 300 Kelvin is 5.2 10 to the power -7. So which of the following will give a precipitate? When does precipitate form? For any reaction to give a precipitate, it must be in forward direction. So we have learned about KSP is given here. We have learned about another term, QSP, that is reaction quotient. So if any reactant to product, K is the value in equilibrium position when the concentration of product and reactant does not change. In case of Q also, it is product by reactant, but it is not at equilibrium. So what happens is, when it is not at equilibrium and when the reaction is going at forward direction, that is concentration of reactant decreases and product increases, therefore Q must be greater than K. And when the reaction goes towards the forward direction, reaction quotient should be greater than K. At equilibrium, Q is equal to K, and when if it goes in the backward direction, Q must be less than K. Why? Because in backward direction reactant increases and product decreases. So in this case we know that precipitate should be formed. So if precipitate should be formed, then the value of Q should be greater than K. We have the value of K, we have to compare the value of Q, reaction quotient. So let's try. Also we have here in the reaction AB2 1 mole, therefore C, and it is in 2C form. So KSP will be C into 2C ka square. So let's put the value and see. (3.6 10 to the power minus 3) 5 into 10 to the power minus 4. This is squared. Why? Because C into 2C. So we are calculating Q. So it comes out to be 10 to the power minus 11. So 10 to the power minus 11, and KSP's value was approximately 10 to the power minus 7, I think. 10 to the power minus 7, so it is less. So next also we can try cube squaring it, C and 2C. So squaring it will be 10 to the power minus 6 and 10 to the minus 4, that is 10 to the power minus 10. So this also doesn't come out. Here it is 10 to the power minus 2 whole square, that is minus 4, and other is 10 to the power minus 2, that is 10 to the power minus 6. 3 can be, fourth is 10 to the power minus 4 and 10 to the power minus 3 squared, that is 10 to the power minus 10. So it is also less. So correct option is C. Next question is, among SO2, NF3, ammonia, XCF2, ClF3 and SF4, the hybridization of the molecule with non-zero dipole moment and the highest number of lone pairs. So let's see the structure. Sulfur have one lone pair and two double bond. NF3 have pyramidal shape and 3 fluorine. Ammonia has one lone pair and 3 hydrogen. Next is XCF2. Xenon has 8 electrons, though fluorine has 2 electrons, therefore 10 electron and 5 electron pair. Out of 5 electron pair, 2 has bond pair, 3 has lone pair. 2 has bond pair because there are 2 fluorine atoms, therefore it comes out to be xenon. Since there are 5 electrons pairs, therefore it comes out to be trigonal bipyramidal. Out of this there are 3 lone pairs and 2 bond pairs. Lone pair always stands out in the trigonal area. Next up we have ClF3. ClF3 also we can see that chlorine has 7, 3 fluorine has 3 electron, that is 10 electron, 5 electron pairs, where there are, out of 5 electron pair, 3 are bond pair, 2 lone pair stands out and 3 bonds pair stands out here. That is lone pair will be in the triangle and fluorine will in the up and down, and if there are excess fluorine they will be in the triangle. We have to first place the lone pairs. Next is SF4. SF4 we have sulfur is 6, 4 fluorine have 4 electrons, that is 10, 5 electron pair, 5 electron pair have trigonal bipyramidal in which 1 electron stands out and the other electron will be in the other positions. It have a shape of seesaw. ClF3 have a shape of says T shape. Now let's see the question asked, which of the following, what will be the hybridization of the molecule with non-zero dipole moment. So out of these I can see only XCF2 have zero dipole moment because the bond moment of fluorine cancel out, so XCF2 cannot be the answer. So HCF2 cannot be the answer. We have to find the molecule with the highest number of lone pairs. So there are one lone pair in each. In ClF3 there are two lone pairs, and SF4 also there are one lone pair. So we have to find the hybridization of ClF3. ClF3 has 5 electron pairs, that is 5 bonds. So the hybridization of 5 bond will be sp3d. So the correct answer will be hybridization of ClF3, which comes out to be sp3d. In hybridization also we know that if there are 4 electrons, hybridization comes out to be sp3. If there is a double bond, maximum chances are of sp2. Suppose some molecule is like this, so the double bond will be sp2. Central molecule, we have to calculate the number of sigma bonds. So the central molecule have 2 sigma bonds, therefore its hybridization will be sp. Here we have 2 hydrogens, so in case of this carbon, number of sigma bond is 3, therefore it has hybridization of sp. Next step is, suppose there are 5 bonds, then hybridization comes out to be sp3d, and there are 6 electron pairs sp3d2. This is the general trend, and also in case of 4 electron pairs there can be dsp2, but it normally occurs with the molecules having d orbitals large size and normally d block elements. So that's all. Thank you.